Hello and welcome to the part 6 of functional interfaces. In this video, we will see how do we give an implementation to a functional interface using a lambda. So in the previous two videos, we have seen how do we give definition to a functional interface using the classical method where we have a class implementer which implements the functional interface calculator in our case, and overrides the add method, giving definition to the add method. Then we saw how to do the same thing using an anonymous in a class. In this video, we will see how do we do the same thing using a lambda. So if you guys remember from the previous video, the implementation that we gave looked something like this. We had to override the add method, and the add method after giving the definition to the add method looks something like this. Now, if you remember from the starting videos where we learned how to convert a method into a lambda, let's apply the same rule to convert this method into a lambda. So what are the rules? Just to recap, rule number 1 was we have to remove the access modifier, the return type, the method name, and add the arrow sign between the parameter list and the method body, right? So let's apply those rules one by one. Rule number 1, remove the access modifier. So we remove public, we have to remove the return type, we remove int, then we have to remove the method name, we remove add, right? And then now what we have is the argument list and the method body. Between these two, what we have to do is we have to apply the arrow function, right? And we apply, and this would convert this method into a lambda. So you can see right? So this is the lambda, and we also learned that we can still fine-tune or make the lambda less verbose. So what are the rules? We don't need to specify or supply the data type of the argument, so we can remove the ints, the data type, right? Int. Using type inference, it will automatically understand what is the type of the argument supplied. The next rule that we learned was if the body of the lambda, this is the body of the lambda, if the body of the lambda just has one statement, in our case it is true, it just has one statement which is return a plus b. So it says if the body of the lambda has just one statement, we can also remove the flower braces or the curly braces, and if we are removing the curly braces, we should also remove the return type. So friends, this method would be converted to a lambda which looks something like this, right? This. Now, so we have successfully converted the add method into a lambda. Now, what is this part? Let's try to understand. So when we started this video, what did we say? We said that we are writing a lambda to give an implementation to the add method of the calculate interface. So this lambda is a definition, is the definition for this abstract add method, and this lambda is of the type calculate, right? Is of the type calculator, right? So each lambda that we define is always linked to a functional interface. Remember that a lambda that we define is always linked to a functional interface, and a lambda is an implementation of the single public abstract method which is defined in the functional interface. In our case, it is the add method which is defined in the calculate functional interface, right? And how do we call this lambda, or how do we apply this lambda? We say calculate dot add. So we call the add method, and the implementation of add method is where it is this lambda. right? So it will call this function, and we are supplying 20, 30, and the answer would be 50. Friends, hope you guys understand this video. We will do a hands-on of what we have learned now in the next video. Hoping to see you there. Thank you.